Example 4. Verify that segments form a triangle, and then is the triangle acute, right, or obtuse? So before we figure out whether or not the triangle is an acute, right, or obtuse triangle, we first of all have to figure out, well, do the segments make a triangle, or are they able to even make a triangle? For example, the example I usually start with is, what if I told you that I had side lengths of a triangle of 1, 2, and 10? Could you put side lengths of 1, 2, and 10 together to actually make a triangle? And most kids will go, okay, well, I have 1 that's maybe this long, and then I have another one that's 2, which would probably be like double that. So 1, 2. Well, if this is 1 and this is 2, then I have to get my third side in there, which is 10. Well, 10's a whole lot longer. 10 is maybe like that long. So how am I going to get a side length of 1 plus a side length of 2? If I put those together, well, that just gives me a side length of 3, and somehow I have to connect it to make a triangle to something that is 10 long. This is not possible. So then the question becomes, well, what has to be true in order for something to actually make a triangle? And the answer to that is, you take the 2 smaller sides and you add them together, and they have to be larger than the third side. So for example, if I take the 4.3 and I add it to the 5.2, that has to be bigger than the 6.1. This will tell me whether or not these can actually go together to make a triangle. So when I add these, I'm going to get 9.5, which is bigger than 6.1. So all this tells me is, yes, you can make a triangle. Now, it doesn't tell me whether or not it's acute, right, or obtuse. It just says, yeah, you can make a triangle. Now we have to figure out, well, is it acute, is it right, or is it obtuse? So we're going to use the Pythagorean theorem, and I'm going to start with small side squared plus other small side squared, and then I'm going to put a box because I don't know if they're equal, and then 6.1 squared. Using my calculator, I'm going to use 4.3 squared plus 5.2 squared, which is 45.53. I'm going to leave my box for now, and then I'm going to do 6.1 squared, which is 37.21. Now, keep in mind when you're doing this, you're always looking at the C value. This is the C value. The C value is smaller. The C value is smaller. So because the C value is smaller, that tells me that this triangle is actually an acute triangle. Letter B. First of all, take the 2 smaller sides, add them together. That has to be bigger than the third side. This is 7 is greater than 6, which is true. So this just tells us, yes, this can make a triangle. Then we use the Pythagorean theorem. Short side squared plus short side squared, box, long side squared. This is going to be 9 plus 16, which is 25, box, 6 squared is 36. Now again, this is my C squared. C this time is greater. So because C is greater, that means that we're dealing with an obtuse triangle. Letter C. First of all, let's just see if this is a triangle. So we're going to take the short side plus the short side, which must be bigger than the long side. So if we take 2.1 plus 2.8, we get 4.9, which is bigger than 3.5. So once again, yes, this can make a triangle. Then we're going to use our Pythagorean theorem. So short side squared plus short side squared compares to long side squared. So now I'm going to take 2.1 squared plus 2.8 squared, which is 12.25. Then we're going to take 3.5 squared which is 12.25, and these are equal. So because these are equal, this is not acute, this is not obtuse, this is a right triangle.